Let me give you an illustration between arithmetic sequences and geometric sequences. So let's say Helen starts a new job at 70,000. So 70,000. And each year, Helen gets a salary increase of 2,000. So now she gets an extra 2,000. And then a year after that, she would get an extra 2,000. So Helen always gets an extra 2,000 each year. Jane here gets a salary increase of let's say 3% each year. So she starts at 70,000, and then the next year her salary would be a 3% increase. Now I'm expecting you to know a 3% increase is simply this times this. I'm expecting you to know that. So her salary in year 2 would be 70,000 times 1.03. Now in the third year, for Jane this is, her new salary, remember her old salary was down here, but her new salary would be 70,000 times 1.03, because this is her new salary. It gets carried across, but then she gets an extra 3%. So it would be this thing times this thing. So it would be 70,000 times 1.03. So this was her initial salary here, times an extra 3%, so times an extra 3%. So now exactly the same times exactly the same. So that would be exactly the same squared. So in the fourth year, her salary would be, well, this was her previous salary, 70,000 times 1.03 squared, and then she gets an extra 3%. An extra 3%. So she would get the whole thing times this thing here, that would be to the power of 3, times her initial 70,000. So the difference here is that, hang on, the difference here is that this one here, for Jane, it would be 70,000 times 1.03 to the power of whatever. So let's call it n. For Helen here, it would be 70,000, and then it would be, remember, each year she gets an extra 2,000, but then you've got to stick an n here. So this n here represents the year. So for any given year, so for example, for year 4, how would you work out how much Helen would get? For any given n, how would you work out how much Jane would get? Well, you would do this, hang on. So notice that each year here you get an extra 2,000, So you're going to need this part here, 2,000 times n. But the thing is, when n is 1, well, for in the case of Helen, you need this special number out here, so that when n is 1, you get an extra increase of 2,000. You see, the number that goes in here would be 68000. So the formula to work out how much Helen would get for any given year would be this. Hang on. It would be this number here. So for Helen, it would be, for any given year n, it would be this number 68000 plus 2000 n. Because look at this. When n is, let's say when n is 2. So what that means is you would jump 2,000 twice when n is 2. So 2,000 here, and this thing here, 2,000 here. So watch this. This thing here is this thing here. Jump 2,000 twice because we're trying to work out year 2. So look, you start at this number here, you jump 2,000 once, and then you jump 2,000 twice. That would take you to your answer. Let's look at when n is 3. When n is 3, it means you jump 2,000 3 times. So look, if you can figure out this special number here, you jump 2,000 3 times. 1, 2, 3. That would take you to here. So the formula for Helen's salary for any given year, it would be given by this. Now let's look at Jane. Jane is like multiplying by this increase of 3% each year. So in the case of Jane, for any given year, for Jane for any given year, hang on, Jane for any given year would be the initial thing, the initial price, the initial salary times notice that you times by an increase of 3% each time. So it would be this number to the power of n. But the thing is, you've got to take this into account. Look what happens when n is, let's say 2. When n is 2, you only times 1.03 once. When n is 3, you times it twice. So you start here, you times it once, you times it twice. So really, to get this to work, you need to minus 1 here. It's always 1 less. And let's try and understand why it's always 1 less. Let's look at year 2. So year 2, n is 2, take away 1, so you jump once. So that would be 70,000, and then you times by 1.03 once. That would take you to year 2. And try to sit there and try and think why you need to take away 1. Let's look at a case where n is in the 3rd year, where n is 3. Well, you put 3 into here, so that means take away 1 will be 2. So that means you jump twice this 1.3. So let's look at this. Start from here, and then you jump twice. 1, 2. It would take you to here. So this one here, you times it by n, but for this one here it's n minus 1. So think about it. Think why this works. Okay.